Okay, so we're recording. So let's go to first PowerPoint. We're going to talk about chemical level of cells, chemical organization. Okay, here we are. So we're all made out of chemicals. We should know, what you should know is that neutrons are neutral, protons have a positive charge. Neutrons and protons make up the nucleus of atoms, and electrons cover the circle around the atom in various energy levels or various distances from the nucleus, depending upon the energy of the electrons, and the electrons are responsible for the chemical activity of atoms. So the nucleus contains protons and neutrons. The protons are positive and the electrons are negative. So if an atom has its complete collection of protons and electrons, it's neutral. You should know that atomic number equals the number of protons and electrons. The mass of protons plus neutrons gives you the atomic mass. An isotope reflects the number of neutrons. For example, carbon, the element carbon has carbon 12, carbon 13, carbon 14 as some of its isotopes. It means that carbon 12 has 6 neutrons, carbon 13 has 7 neutrons, and carbon 14 has 8 neutrons. So as long as a substance has the 6 protons, it's carbon. If the number of neutrons vary, we can have isotopes. The average weight of the isotopes with their percentage of abundance gives the atomic weight of an element. Electrons surround the nucleus. They're organized in shells or energy levels, or each shell is a certain distance from the nucleus, depending upon the energy of the electrons in a particular shell. All you got to remember is the outer shell determines chemical properties. So you should know about protons, neutrons, electrons, atomic mass, atomic weight, and atomic number. So I just talked about the carbon atom: 6 protons, 6 neutrons, 6 electrons. 6 plus 6 is 12. That's the atomic mass. You can see there are various levels of three-dimensional shells around the nucleus of protons and neutrons. The neon atom has 10 protons, 10 neutrons, and 10 electrons. Neon is very, very stable, but remember, the outer shell electrons determine how a chemical reacts. So read that. That's what we're talking about. That's why we're talking about physiology at the cellular level. An atom, the chemical bonds of atoms transfer or lose or gain electrons, and we get ionic compounds, and we get ionic compounds where electrons are gained or lost, covalent bonds where electrons are shared. An ionic bond happens when electrons gain or lose electrons. If electrons are lost, the ion is positive. If electrons are gained, the anion is negative. They attract one another, and that forms an ionic bond. So here's an example. Sodium has 11 electrons. It loses one to chloride, to chlorine gas, and becomes chloride. You see chlorine atom, chloride ion. Sodium keeps the same name. So this sodium now has 10 electrons with a positive charge because it's lost one electron to chloride. Chloride has now 18 electrons and it now has a negative charge. So sodium positive is attracted to chloride negative. That's an ionic bond. That's an ionic compound such as table salt. When the ions of sodium are attracted to the ions of chloride, that's a salt crystal. Those are ionic bonds. Ionic bonds often form crystals. These ions are very, very important in the functioning of your body at the chemical level, at the basic physiology. You should know these symbols and these names. We'll be talking a great deal about sodium, potassium, calcium, bicarbonate. So these are the most common ions in body fluids. You should know the symbol, you should know the name. So those are things that you'll have to be familiar with in order to study the physiology of cells. Covalent bonds, electrons are shared. When electrons are shared, the outer shell is complete because each outer shell has a standard capacity. So when electrons are shared, that's a covalent bond. One shared pair from each atom is a single covalent bond. Sharing two pairs, one from each atom, is a double covalent bond. So hydrogen shares a pair. Hydrogen exists as called a diatomic molecule. Oxygen is diatomic. Oxygen shares two pairs. Each line represents a pair of electrons. Carbon dioxide shares two pairs of electrons with each oxygen. And the carbon has a total of 4 single bonds, 4 shared pair of electrons. We'll find out that the oxygens are slightly negative in carbon dioxide, but since they're in a line, their attractions cancel one another out, and the carbon dioxide molecule is neutral. Okay, so let's keep going on that chemical information. So if the electrons are shared equally, that's a nonpolar covalent bond. If electrons are shared unequally, that's a very, very important in water where there's a hydrogen-oxygen bond. So know what a polar covalent bond is and a nonpolar. Equal sharing is nonpolar, unequal sharing is polar. So hydrogen bonds are weak bonds between a polar bonded hydrogen and a polar bonded nitrogen. So if you look at water, water has a slightly negative oxygen, slightly positive hydrogen. That dashed line represents a weak attraction called a hydrogen bond, and it explains many, many, many characteristics of water, such as high boiling point and the ability to be a universal solvent, have a very high heat capacity because these hydrogen bonds have to be broken. That's very important because water is the main way we cool ourselves and the main reason humans, for better or for worse, can spread all over the earth. But it's getting hot. It's getting hotter, so there's going to be increased sweat stress on any humans that live in a very hot environment. Air conditioning costs are going to go up. So please vote for people who believe in climate science. Okay, so there are compounds that have a particular structure. Ions are charged, and I told you what elements you have to know, such as sodium and potassium, and water and carbon dioxide and bicarbonate. We know that chemical reactions involved reactants and products. Reactions take place all over the body to make nerves work, to make muscles work, to dissolve and digest your food. We don't need to know that. You should know what potential energy is: stored energy, and kinetic energy is the energy of movement when the potential energy is converted into movement. We're not going to worry about these reactions. We will talk about hydrolysis in a moment. We'll see where that happens. And we'll kind of talk about dehydration synthesis in a moment. Anabolism is all the reactions of the body to synthesize compounds. We don't need that one. Reversible reactions we will talk about, particularly with carbon dioxide and water. Cells cannot capture or use heat energy. That's how we keep our body at a certain temperature. Okay, let's stop there and go back to here. Let's stop recording for a moment